So I hope you're able to see. Right. So in the previous class, we started the chapter system of particles and rotation motion, right? So our main concept of discussion in the previous class was about a concept named center of mass. And we saw what is the formula for center of mass and all other center of mass for a system along x-axis, y-axis, and z-axis, right? So that's what we were doing, and we solved a problem also. So if you observe, that problem is something similar to example 7.1 in your textbook. Find the center of mass of three particles which are lying at the vertices of an equilateral triangle. The masses of the particles are 100 grams, 150 grams, and 200 grams respectively. Each side of the equilateral triangle is 0.5 meter long. So these things, it's similar to how we solved the previous problem. So what was the formula? X coordinate of the center of mass is m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Similarly, for y direction, it is m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. All those things. Okay. Similarly, what we will do is, we will slightly extend this concept. Okay. So, for n particle system, okay, observe. For n particle system, can I say that the x coordinate of center of mass is m1 x1 plus m2 x2 plus so on till mn xn, the whole divided by what? The whole divided by sum of all the mass. m1 plus m2 plus so on till m. Okay, this is the x coordinate of center of mass. The question is, what will happen if I differentiate on both sides with respect to t? Okay. So if I differentiate with respect to t, I'll get derivative of x coordinate of center of mass with respect to time is equal to 1 divided by m1 plus m2 plus so on till mn into m1 into derivative of x1 with respect to t plus m2 into derivative of x2 with respect to t plus so on till mn into derivative of xn with respect to t. Okay. So derivative of x coordinate with respect to center of mass will give us the velocity of the center of mass along x direction. So why we need this concept is because when you have an n particle system, it is not like always the n particles are going to lie at rest. They can move also. If these n particles are moving, then how is the velocity of the center of mass associated with it is what is the question. So this will be equal to 1 by, can I write it as sigma of all the masses? I will write sigma mi, where I is equal to 1 to n, into m1 into derivative of x1 with respect to t is nothing but v1, plus m2 into derivative of x2 with respect to t is v2, plus so on, plus mn into derivative of xn with respect to t is vn, right? So the velocity of center of mass along x direction will be equal to 1 divided by sum of all the masses into this m1 into v1 will be the linear momentum of the first particle, plus m2 into v2 will be the linear momentum of second particle, plus so on, plus the linear momentum of nth particle. The only difference is going to be we are going to write it in the vector form. Okay. So the velocity of center of mass is given as p1 vector plus p2 vector plus so on till pn vector, the whole divided by sum of all the masses. Okay. So this is along x direction, guys. Similarly, if it is along y direction, you write it as, okay, I'll bring a small difference in this. Okay. Observe. I'll call it as P1 along X, P2 along X, and Pn along X. So this is how it goes. So write it down. So I hope by now you have understood along y direction. You should write P1 along y, P2 along y, like that. So that is the way you write it. Okay. I hope you finished it. Now the question is, if you differentiate second equation with respect to time t again. Okay. So if you differentiate it with respect to time, then you will get derivative of velocity of center of mass with respect to time is equal to 1 by sigma mi, where I is equal to 1 to n, and derivative of p1 with respect to x with p1 of x with respect to time plus derivative of p2 of x with respect to time plus so on till derivative of pn of x with respect to time. Okay. So derivative of velocity of center of mass with respect to time will be what? It is the acceleration of center of mass. This will be equal to 1 divided by sum of all the masses into I is equal to 1 to n. What is derivative of linear momentum with respect to time? That is, the rate of change of linear momentum is what?
Omega.
Huh? Well, you are not supposed to forget this. The rate of change of linear momentum is what? I have told this many times. It is from your 4th chapter.
Resultant.
Huh?
Resultant
Resultant of what?
of force acting on the mass.
There is nothing like resultant of something. You should say resultant of a particular physical quantity. How can you people forget? Huh? Somebody told.
Force.
It is force. So how can you people forget this one? What is this actually? What is rate of change of linear momentum? What law is that?
Newton's second law.
Second law.
Yes, then why are you people not answering? So it is force acting on the first particle along x direction plus force acting on the second particle along x direction plus force acting on the nth particle along x direction. Okay. So if you have sum of all the forces acting along x direction, see, I'll write an additional step. Listen. So acceleration of center of mass along x direction is equal to 1 by sigma mi, where I is equal to 1 to n. Can I write this as sum of all the forces acting along x direction? Okay. So from this we can conclude that sigma fi into x, where I is equal to 1 to n, is equal to sigma I is equal to 1 to n mi into acceleration of center of mass along x direction. If you observe this, there is nothing but The total force is equal to the total mass of the system into acceleration of center of mass. What is this? F is equal to ma. This is also Newton's second law, meaning when we were solving problems in the previous chapter, what we were doing is, when we took a solid, we would have drawn the diagrams like this, acceleration, right? We wrote many times that F is equal to ma. This acceleration, whatever we are trying to talk about, is the acceleration of whom? It is the acceleration of the center of mass of the system. At that point, I couldn't explain it. The meaning of it is, the solid will be made up of many particles, and let's say its center is somewhere at the midpoint. Then it is the acceleration of that particular particle, which we were writing it as F is equal to ma and solving the problems. So this is what is Newton's second law. Write it down. Okay. So this is all with respect to point objects. Okay, this is all with respect to point objects. Okay. Next is, what if you have extended objects? Extended objects in the sense, let's say you have a thin rod like this. So if you have a thin rod of length L, okay, where will the center of mass of the system be? If you have a thin rod of length capital L, where will the center of mass of the system be?
Enter.
It will exactly be at the midpoint. It will be L by 2 from either of the sides. Right? So when you have extended mass, write down this formula. So this will be the formula for x coordinate of center of mass, integral of y dm divided by capital. So I'll tell you, wait. So this is the formula, okay? Just write down the formula, that's enough. So integral of x dm divided by capital M. Similarly, y coordinate of center of mass is integral of y dm divided by capital M. Similarly, for the z coordinate of center of mass, it is integral of z dm divided by capital M. Okay, 1 by m into integral of y dm. So these are all the coordinates of the center of mass along x, y, and z direction for extended objects. Okay. Now see. So previously, whatever I discussed was motion of center of mass. So you're able to see this, right? So this is what I previously discussed, which is also there in your textbook. You can go through it later. Okay. Okay. So again, So with this, the center of mass concept is over. We will do one problem before we proceed to the next exercise. You see, there is a question. Find the center of mass of a uniform L-shaped lamina. Lamina is a thin flat plate, okay? L-shaped lamina with dimensions as shown. The mass of the lamina is 3 kilogram, okay? So dimensions are shown. So meaning of this is, this whole part is completely there. So this whole part is there. Okay. Similarly, this part is also there. Are you guys able to understand? So this is how the lamina is. For this kind of a system, you need to find where the center of mass of it is. So this lamina, what we can do is, we can assume that the mass is uniformly distributed. Uniformly distributed in the sense, if you take the first portion alone, the topmost portion, then the mass of this portion will be 1 kilogram. Similarly, the mass of this portion will also be 1 kilogram, and mass of the third portion will also be 1 kilogram, such that all the weights, all the mass put together will give you a total mass of 3 kilogram. Okay, that is what is going to happen. Next. Now, how to proceed? Okay. So here, do you have point object or extended object?
Extended.
So you have an extended object, meaning you cannot apply the formula here because it's an extended object, but it has a uniform shape. It takes the shape of a square if you observe it. All right. So what you can do is you can convert this extended object system into a point object system by doing some manipulation. What manipulation you're going to do is, the first block is there, right? If I take this bottom block as the first block, it is a complete rectangle. But that complete rectangle's center of mass will be at some point. Where will it be? The complete
D.
Sorry, it will be at the point C1. C1 is a coordinate of the center of mass of the first block. Okay. So since it is taking the shape of a square, the center of mass of the first block will exactly lie at the point of intersection of diagonals. Okay. So if I take this point as 1, 0, then what will be the coordinate of this point? Similarly, if I take this point as 0, 1, what will be the coordinate? Sorry?
0.
Point?
0.5, 0.5.
It will be 1/2, 0. The bottommost point. I asked this point.
Okay, sir. I told.
What? Yeah, I understood. So C1 will have the coordinates as 1/2, 1/2. Since it is exactly the midpoint, right? Similarly, what will be the where will the center of mass of the second block be? That is, what will be the coordinates of point C2?
One 1.5, 1 point.
1.5, 0.5.
1.5. Yes. It will be 1.5, 0.5. Very good.
0.5.
That is 3 by 2, 1 by 2. 1 minute. Okay. What about the coordinates of point C3?
1 by 2, 3 by 2. Sir.
That's right. 1 by 2, 3 by 2. So, this whole laminar system, can I convert it into a 3-particle system like this? Right? I can convert it into a 3-particle system in such a way that at C1 there is a 1 kilogram mass line, C2 there is a 1 kilogram mass line, and C3 also there is a 1 kilogram mass line. And C1 has the coordinates of 1 by 2, 1 by 2. C2 has the coordinates as 3 by 2, 1 by 2, and C3 has the coordinates of 1 by 2, 3 by 2. Now, what will be the center of mass? X coordinate of center of mass will be equal to m1 x1, 1 into half plus 1 into 3 by 2 plus 1 into 1 by 2, the whole divided by 3. Accepted? So this will be equal to 4 by 2 by 3. That will be 2 by 3. Right? Similarly, what will be the y coordinate of center of mass? m1 y1, 1 into half plus m2 y2 plus m3 y3, the whole divided by 3. So 1 by 2 plus 1 by 2, 1 plus 3 by 2 is, did I make a mistake? It is 5 by 2, right? So it will be 5 by 6. Similarly, here it will be 1 by 2 plus 5. This will also be 5 by 6. Accepted? So what will be the center of mass position? It will be 5 by 6, comma. So did you guys understand this?
Yes, sir.
So it is exactly at 5 by 6, comma 5 by 6. This will be the required answer. Okay, next. So we have completed the first part of the show. So in the second part, you have the vector product of two vectors. This I have already discussed in the vectors concept, but I will revise it again. Okay, this is very, very important for this chapter. So we have completed center of mass. Now we are going to discuss about rotational mechanics. Okay. Now we are going to discuss about rotational mechanics. The question is, before we get into all these vector products and other details, let's first try to understand what this rotational mechanics is all about, or I can say rotational motion also. Right. Now the question is, we have already discussed something called as circular motion. Right. So what is the difference between circular motion and rotation motion. When we have already studied circular motion, why are we having a separate chapter named rotation motion? That is an important question to answer. So why are we having it? You can try.
Sir, circular motion is because of centrifugal force, sir. Rotational motion is due to the torque, sir. That moment of force.
Okay. Okay, partially right. That's right. So what happens in circular motion is, when you talk about a particle which is moving in a circular motion, the first and foremost point to be known is, say for example, we would have discussed about a car which is moving in a circular motion. So car, does it have a finite size or is it a point sized object? I asked a question.
Point size, sir.
Point size compared to what?
Compared to the ground, the circular ground.
Compared to the track on which it is revolving, right? So
Yes, sir.
here tell me one thing. So I'm going to put certain questions to understand. Car has the wheels associated with it, right? Car has wheels with it. So the car, when it is trying to turn on the circular road, is the car undergoing circular motion or rotational motion? Is the car rotating or is it circulating? Try to understand my question. Is the car trying to rotate or is it in a circular motion? So this is what we need to understand.
Circular motion.
It is in circular motion. So why we are able to say it is in circular motion is because compared to the size of the track, it is being treated like a particle. So when you talk about a particle, the particle is revolving around a center. When a particle is revolving around its center, it undergoes circular motion. Okay, did you guys understand? Are you guys clear with this? So car as a whole is in circular motion. Whereas if I ask you about the tire of the car, is the tire of the car undergoing circular motion or rotation motion?
Rotational motion.
Yes. So the car as a whole is undergoing circular motion. Whereas the tires are undergoing what motion? Rotational motion. Are you guys clear with these 2 points? Okay. Now we will try to answer the questions. So how exactly can you differentiate whether you are going to talk about a circular motion or rotation motion? Okay. So when you talk about this tire, okay, when you talk about this tire, the tire is going to revolve, right? It is going to revolve around something called as axis of rotation. Okay, just give me a second. I'll demonstrate it. Maybe not with a tire. I'll show with the pen. I'll show you what is the difference. Are you guys able to see me? See, if I take this pen, okay, the center of mass of this pen is somewhere over here. This I demonstrate from, right? If I take this pen and revolve it, okay, can I call this as circular motion or rotation motion? Is a pen as a whole, okay, is a pen as a whole in circular motion or rotation motion? What will be your answer?
Rotational.
The pen is rotating, yes, that's right. But this pen is made up of many particles, right? If suppose, let's say, you're able to see this letter. You're able to see this letter, right? So if you take that letter as a small particle, when the pen as a whole is revolving, what can you say about that letter? What can you say about this letter? Is a letter in circular motion or rotation motion?
Circular motion.
Yes, that's right. So, for what kind of objects do you speak about rotation motion?
Earth.
I'm not here. I took a pen. Why did you go tell Earth? So, when I take a pen and revolve it, is the pen when I use it, is it rendered like a point object or extended object? Yes. So rotational is large-sized objects. To put it in simple terms, you cannot call it as large-sized objects. You can call it as objects with finite size. Okay. So that is why if you see those finite-sized objects in this particular chapter, we call them as rigid bodies. Rigid bodies in the sense solids, where the distance between two particles of that system is always fixed. For example, this pen, if I try to apply the pressure, I'm not able to deform it. So approximately I can treat it like a rigid body. Rigid bodies are those where the distance between the subsequent particles or distance between any two particles is always a constant. So when you talk about a finite sized object which is put into a motion about a fixed point, then we call it as a rotation motion. Whereas the particles of the rigid body will have a circular motion about a fixed center. Okay, am I clear till this point? Is there any doubt?
No, sir.
Okay. And one more important point to be spoken about is when you talk about circular motion will happen around a point called as center. Okay. So what is center? Center is a fixed point about which. Am I clear with this? So when you speak about circular motion, we use the word center. I'm repeating it, listen. When you talk about a particle which is in circular motion will happen about a point called as center. About a fixed point called as center. Whereas rotational motion will happen about a fixed imaginary line called as axis. So when I say this pen is revolving, I have to say that this pen is revolving about an axis like this. It is like this. You're able to visualize this. Whereas you take a point on the axis which is exactly coinciding with the pen, that point will be called as the center. Each particle is revolving about the center. This pen as a whole is revolving around about an axis. So whenever you talk about rotation motion, the first and the foremost point that we need to define is axis of rotation. Are you guys clear with this? Did you guys understand what I'm trying to ask?
Yes, sir.
So similarly, you have fan. You have a fan at your home. So is a fan revolving? Is a fan in circular motion or rotation motion? The fan in your house. Is the fan in circular motion or rotation motion?
Rotational.
Circular.
The fan is rotating, but no, fan is in rotation motion. The fan is rotating, but each particle which the fan is made up of is in circular motion.
Circular motion.
Okay, and the fan is rotating about which axis? The fan is rotating about the axis along which it is suspended. There will be a rod, no, in the center. They will try to put the rod about which the fan will revolve. So that rod will act as the system of the system. Are you guys able to understand this point?
Yes, sir.
Okay. So when you talk about rotational motion, you speak for rigid bodies. It need not be rigid bodies. It can be extended objects also. In this chapter, we'll be considering the rigid body. So what do you mean by rigid body? Any object where the distance between the particles are always fixed is what we call it as a rigid body. I hope you understood. Okay. So for you to speak about rotational motion, the most important point to be defined is axis of rotation. So what do you mean by axis? Axis is an imaginary line about which the whole system is revolving. So it is imaginary line about which the whole system is revolving. That's what we call it as axis of rotation. I hope it is clear, guys.
Yes, sir.
Okay. Next. Similarly, when you talk about axis of rotation, it is basically classified into two types. One is called as natural axis. See, generally they don't use the word natural axis. They simply call it as axis of rotation. And the second is called as instantaneous. Okay, I'm just putting the word natural to it. So what do you mean by natural axis of rotation means? It is imaginary line. It is imaginary line passing through center of mass, or you can call it as center of gravity also. Instantaneous will happen to be defined at any point other than center of mass. So if you're able to rotate the pen about any other axis other than the center of mass, then you're rotating about its instantaneous axis of rotation. About this we will discuss when we go into the other concepts. Okay, are all these points clear?
Yes, sir.
Okay, so next we need to understand certain important points here. That is, so have these 2 points in your mind. Now I'll just revise the vector product concept. So vector product is also known as cross product. So what do you mean by vector product? Observe. If two non-zero vectors, A vector and B vector, are present, then A vector cross B vector is given as magnitude of A vector into magnitude of B vector into sine theta n cap. So this you already know, right? So A vector cross B vector. What is magnitude of A vector? Sorry, magnitude of A vector into B vector. What does theta stand for? Theta is the angle between A vector and B vector. And what does n cap stand for? it is a unit vector perpendicular to both A vector and B vector. Okay. So if you talk about a vector, unit vector which is perpendicular to both A vector and B vector, that is what is called as this n cap. Okay. So since the output is a vector quantity, that is why we call it as vector product also. Okay. Similarly, if you have I cap cross j cap, it is k cap. So that is, if you take I, j and k in the anti-clockwise direction, then you will get the positive value. If you take in the clockwise direction, you get negative. The meaning of this is, if you do I vector cross j vector, that will be, sorry, I cap dot j cap will be k cap. Similarly, j cap cross k cap will be I cap, and k cap cross I cap will be equal to j cap. Okay, because they are going in the anti-clockwise direction. Whereas if you do j cap cross I cap, it will be minus k cap. Similarly, k cap cross j cap will be minus I cap. Similarly, I cap cross k cap will be minus j cap. These are all the other important points to be kept in your mind. I hope it is clear.
Yes, sir.
Okay. So, there is some basic outline regarding the vector product. Okay. So, this is sufficient for you to apply in this, in the concepts that you are going to discuss now. So, based on all these things, now I am going to introduce a concept called as torque or moment of force. So, we already saw what is moment of force. Moment of force is nothing but force multiplied with the perpendicular distance. Right? Force multiplied with the perpendicular distance is going to give you the moment of force. Now, see. If I take this as the axis of rotation, if I apply a force which is at a distance of r vector from the axis of rotation, okay, then F vector is like this. If this is the particle P, if this is O, then the torque experienced by particle P is given by the formula about the axis of rotation is given by the formula. Torque is represented by this symbol. The symbol is called tau. It's a Greek alphabet. Okay. So tau is equal to r vector cross F vector. So write down this definition. So torque as a vector is equal to r vector cross F vector. Okay. So for today, I will tell you how to use this as a formula. Tomorrow, I'll explain what is the significance of it. Okay, how to visualize it, I'll explain it tomorrow. See, suppose they are put a question like this: find torque experienced by a particle whose position vector is r vector is equal to I cap plus j cap plus k cap meter, and F vector, the force experienced by it is 2i cap minus 3j cap plus 5k cap Newton. Okay. If suppose they give you this kind of an expression, or these variables and values, our work is to find torque using the basic formula R vector cross F. Okay. So how to find it up, sir? So torque vector, what is the formula? It is R vector cross F vector. Accepted. So what is R vector? It is I cap plus j cap plus k cap cross F vector is 2i cap minus 3j cap plus 5k cap. Okay. 2i cap minus 3j cap plus 5k cap. So how to do the cross product is, if you recollect, there is a method called as determinants method. You write I cap, j cap and k cap. Right. Below I cap, j cap, k cap, you need to write the coefficients of I, j, k for the first vector. So this is the first vector. The coefficients are 1, 1 and 1. Then below that you need to write the coefficients of the second vector, that is 2, minus 3 and 5. Right. Then what are we supposed to do? First write I cap. Who can tell me?
Sir, we have to block I and this, and then cross multiply j cap and k cap, sir.
Yes. So you need to cross multiply these two values. You need to hide this column and this row. Then what is it? You will be able to see 1, minus 3, 1 and 5. So cross multiply these two and subtract. 5 into 1 minus of minus 3 into 1, that is minus 3. Then what are we supposed to do? You need to start with plus, minus and plus. Minus j cap into, you need to hide j cap and that is a column below that and the row along it. So you will be able to see 1, 2, 1 and 5. Again cross multiply and subtract. That will be 5 minus 2. Right. Plus k cap into, you need to hide the corresponding row and the column, 1, 1, 2, minus 3. That will be minus 3, minus 2. Right. That will be I cap into 8 minus j cap into 3 minus 5k cap. Did you guys understand? So torque vector is equal to 8i cap minus 3j cap minus 5k cap, and the answer for this is Newton meter. We saw Newton meter somewhere else also. Where did we see? Where did we see Newton meter?
So joule, sir.
Where did we see? Joule is for what?
Force. Work.
It is work done, right? Here also it is Newton meter only. But here this Newton meter cannot be called as joule, because joule is the SI unit only for work done. Okay. Just because here also it is Newton meter, don't write it as joule. That is what I wanted to stress upon. Okay. In torque, we are only going to call it as Newton meter. Are you guys able to understand? So I'll give you one more problem. So R vector is equal to I cap plus j cap plus k cap, and force vector is 2i cap plus 2j cap plus 2k cap. Find torque. Good, fast.
So 0, sir.
Why?
So 0, sir.
Yes, that's right. So torque will be 0. Okay. So why, if you observe this problem, you can directly itself say R vector and F vector are parallel to each other. Okay, if they both are acting in the same direction, then the torque will be 0. But similarly, you can do it in this determinant method and also prove it. Okay, so torque will be 0 in this case. I hope it is clear. Right. So similarly, I'll give you another formula also. Torque can also be written as Rf sin theta. So torque vector is Rf sin theta n cap. If you write only torque, it can be written as Rf sin theta, or this can also be written as force into perpendicular distance. Okay. So there are different formulae for torque. What is it? Torque vector can be written as R vector cross F vector, or torque vector can be written as Rf sin theta n cap. Similarly, torque can also be written as Rf sin theta. So observe the difference, okay? The first two I've written it in vector form, the third one I've written it in the scalar form. Here, this is read as into, don't read it as cross, because for scalar quantities you read it as into, for vector quantities we read it as cross. Okay. So this is all about the outline of torque. What is the significance of it? How to visualize it? I will explain it. Okay. I hope the mathematical formula and everything is clear, right? How to solve a problem if it is given. I hope it is clear. Yes or no? Okay. So this is all about the basics of rotation motion. This is all for today. Just wait. Don't leave.